All right. Let's do the power-ups, which we have to add to our construction mode. Let's see. We have to export all the level data first, so that makes sense to do that first. Because right now we are parsing the dumped level data, and we need to parse the actual data that's in the ROM. So yeah, let's take a look at that first, I guess. Yeah, let me export that. That's on the C++ side. Which we will export base64 as a base64 string to a JSON file, which we can import in the online construction mode thing. But that means we have to store the data though, which we don't do in round. Yeah, we don't store, like we interpret all the data, but I don't think we actually store what is being passed in the constructor here, which is this. Yeah, so we have to pass that data onto our base64, yeah, this guy here, and that's just start, begin, and end, so we can just do that instead of all this and do that logic on the JavaScript side. So let's try that. So we are getting this as the input, which we are going to save. And then in our parse function, we will save this. Let's make a copy of this. All right, so that should still compile, and then we have our raw data available to dump. So instead of, where is it? Yeah, instead of this one. So let's comment all of this out. I'm not going to do any export of power-ups, nor the actual interpreted level data, but rather let's do this. And then n of raw data too. So that means that if we run it now, we should get a base64 string of the entire raw data of the entire level. So let's run this. Right, so that's this information. So these are all the levels, right? So that's all interpreted, but we want it uninterpreted, so we can, yeah, so for example, for level 125, we have just the data now. So let's see how that goes. I think it's in JS, E1 levels. Right, so now we're writing that information to E1 levels. So we are back here. Right, so that's all our information here. Now we have a D and an R. R is a round number, and D is the data. So let's, I mean, this is going to fail now, right? Because that's missing information completely. So now we have to add a function to decode the level. Right, what did we change here? Oh, the line. Okay, that's fine. So let's add a function to decode the data. That is called, what was it called here? Fetch Eggerland 1 level. Yeah, so we are loading D here. And we have our bytes. Okay. Right, and we're just copying these bytes. So we are actually going to have to, I want a decode function and an encode function, because we're going to have to save to disk file as well. Let's see. Yeah, so these bytes, this is actually correct, right? So I don't remember why we're doing this charcode add thing. Oh, yeah, I guess we're just converting it into a uint8 array, right? I also have to reload the E1 level thing just to make sure it's the latest version, because otherwise, yeah, okay, that is correct. Well, I'm gonna need the console though. Right, so we have our data here. Let's look at the first level. I'm going to open that up in MSX itself. So let's open our pointer to, I think it's this one, is it? No, a special word being shown. No, that's not the one. So let's close the tile viewer here. And I mean, the data should already be there. We are fine being in this state of the game. I just have to look up, what is this? Okay, no, that's our C000. Okay, what do I have here? Oh, these are functions. Okay, so I have to look in the sim file because I don't know this by heart. C81B is our, yeah, so C81, oh no, that's current level. I'm looking for level data, which is 65.6, and that would be D5 is the first pointer here, is what we're looking at, so that's D5F8. And that is indeed our round 1. And we're starting with 4 zeros, well, 3 zeros for the 3 power-ups, and then low index is 0, 0, and then 8x5y is our exit or index. And then we have A5, so 165 bytes worth of data. So it should stop at A8. Okay, so let's verify that this is the data we get. Well, we already dumped it, I think. Yeah, so 133. Of course, it's not in hex, but that's fine. Yeah, so 85 is 133, and we should end with 168, which is A8. Yeah, that's okay. So that's correct. We have our bytes here. That's weird though. So we have 165 for length, but we only have 42 bytes. How did that work? Is that not? Yeah, something's going on with that too. That's not correct. Because we have 42 bytes here, right? From, here to here, or from here to here, I guess. 16, 32, 3, 4, 5, 35, 36, 37, I guess 38, 9, 40, 1, 2, 3. Yeah, so we have 40, well, 42 then, I guess. That's a bit weird. Why is the length not? I mean, this might contain other information as well, though. I'm not really sure about that, because it's definitely not 165 bytes. So we have the 3 power-ups, the positions, and the length would be the next one, right? Yeah, so this is 175 bytes. That doesn't seem correct to me. Yeah, we do have 43 bytes because we are starting at 0, of course. Yeah, that doesn't make sense. Oh, that means I have to look at this one, though. That doesn't really make sense. I'm going to add a watch point on this one, and I'm going to look when this is red. No, read memory. I'm going to start the first level, which it's then going to need to access, and see if that byte is used in a weird way. Let me focus on OpenMSX here. Yeah, so we've broken now. Yeah, we're on break. And we're loading this value. So HL is pointing to D5FD, which is this one, right? So we're looking at the, oh, did I? No, this one, this is the linked one. Okay. So we're looking at D5FD and we're ANDing it. Okay, so this one also contains multiple informations. That's because C7F, if you look at that, that's a specific, like the top 2 bits or something, or the top bit, I don't know. Or the bottom 7. Let's see, 7F is, yeah, the bottom 7. So everything except the top bit. Oh, yeah, it was the algorithm. Yes, of course, I forgot about that. Of course, we already figured this out. This is the top bit determines the algorithm, either horizontal or vertical, and the bottom 7 bits indicate the length. So if we do take out the top bit here, so A5 is 165, as we saw, which is way too much. But if we disable the top bit, then we have 37 left, which is the amount of bytes. Okay, so yeah, it was algorithm determination that is included in this byte. Okay. Let's start with parsing out the power-up data, which also has to be split, as in the top 2 bits and the bottom 6 bits. Top 2 bits being the amount or the ID of the power-up, and the bottom 6 indicate how many hard framers you have to pick up for it to activate. So let's see. I'm going to put this in a decode function, though, because these 2 lines are applicable for fetch Eggerland 1 level, and I'm going to do a decode function. Okay, so this goes here, and then what we need to return is like a little class, I guess. Let me add that then. And we have a power-up 1 type. Let's put it as a string. No, it's equals, okay. And then we have power-up 1 hard framer count. 0. So let's parse out these values, see if we can do this. Where's our decode? So round equals this decode round data coming from this, right? So we are loading the round number -1, of course, because we're indexing into the array. The array Eggerland 1 level data is 0 based, contains all the rounds, but it's 0 based, right? So the round number, I want to pass a round number here that makes sense. In other words, from 1 to 100 or 15 or 25, whether you include the extra rounds or the bonus rounds as well. So then we have a round, and the round is going to be an instance of this class. So round data that's just data, right? So const round equals new Eggerland 1 round. Can I access? I think I can access those variables. So and then we return a round. So we decode data D. Right, so we are so we decode the data. We have the pies in the uint8 array. Okay, so that's what we have to look at now, right? I mean, we should put some error checks in there. It has to be at least, I mean, I did this in the C++ version as well, of course. Let's see. The first check I'm doing here is checking whether the data size is at least 6 bytes, right? If data length smaller than 7, return no. And then, right, so we're ending with C0 to get the top 2 bits, and that's our type. Okay, so I don't know enough JavaScript off the top of my head to be able to do this. I think I can do this, and I shifted my 6. Does this work? Okay, that seems to work. So let's do all 3 of them. Oops. And that would be 1 and 2. Okay. Okay, they are 0, 0, 0. That makes sense because the first 5 levels do not have power-ups, but level 8 does, if I remember correctly. So let's load A instead of load the 5. So let's start at level 8, and then 8 plus 5. yeah, power up 1 equals 2, and 2 we know is, if we go look at the definition here, 2 is an arrow, and I think that's correct. Right, well no, I need that because I need the values here. I'm going to add these as power up arrow equals 2, bridge is 1, none equals 0, and framer equals 3. And we have to have, I mean, this mapping, that sucks though, but well, no, I mean, we can just do this, right? Instead of strings, we use this. And we can just assign now yeah, that actually works, right? If it's an arrow, then we print, which should be the case for the first one, right? No. And oh, the second one is undefined. Is that not accessible? Yeah, that's not a. Hi Toby. Yeah, I've been sick for a bit. I have started working on re-implementing the construction mode from Eggerland into a little web app, so we can create levels online instead of having to use the in-game construction mode. So that's what I'm working on right now. But yeah, I'm just struggling with JavaScript a bit, which is fine. But yeah, it's a bit clunky. I prefer C++ here. Right, can I not access these? Oh, wait. I can use round though. Round. Yeah, so that does work, 2 and 2, and power up 1 equals 2. Okay, so I can compare these with our definitions. Okay. Let's see. So we have the power up type. Now we need to extract the amount of hard framers you need. And in C++, we did that by looking at the bottom 6 bits, which is just an AND, of course. So round power up hard framer count for the first one equals bytes 0 and what was it, 3F, that's the bottom 6 bits. And now we have those values too. Okay. Actually, let's put a function, a dump function in here, and then we can do this. Round dot power up hard frame count. Okay, so let's add that. And then we can use the dump function. That's a bit easier. Let's see if we're dumping. Okay, around is not okay, right? Of course, this should be this, not around. Okay. Yeah, 2. Yeah, that's good. Let's see. We have to extract. Yeah, this one is being loaded. Wait, why did that not? Yeah, I need to do this conditionally though. Yeah, let's dump this conditionally. If power up one type not equals this point, none. Right. Otherwise, we're dumping extra information that we don't really need. So power up 2, and then same with power up 3. Right, so now we only have the applicable power-ups. We need 8, we need 3 and 5. I think that's correct. So let's dump this to be certain. Let's look at, yeah, this dump for level 8 has an arrow and 8 hard framers required. And that's what we see here, right? Power up 2 is an arrow, I think. Yes, and that is 8 hard framers required. Okay. Good. So that is extracted now. Let's forget my place here. Okay, we're about here. Okay. Then what is next in the data? Let's look at the C++ code again. So we have our power-up information. Okay, Lolo's position and the exit position. Okay. That would be Lolo position equals 0 and exit position equals 0. And that's just a simple copy of data because we only have to do Lolo position equals bytes 3 and 4. Yeah, bytes 3 and 4 is exit position. We can dump this as well. Let's dump the round number 2 though. What is this constructor thing again? Just like this. Okay, then we console log round we have to save this value, of course. This round number equals round number. Okay, and we will have to pass the round number, I guess. Well, no, that's included in our thing here. So let's see. We do know the round number from our data here. Yeah, that's included. And then we can include that here in our dump, which we did. Let's see. So we have Lolo position now. So let's dump that one too. Lolo position, exit position. Okay, let's see if it does that. Yeah, so round 8 has 1 power up. Let's capitalize the power ups. And we have Lolo position 122. Okay, can I do this in hex? No, I want this in a, what is this called? An f-string template literal. Oh, that's Xcode. That's not going to be supported, I guess. Oh, we do have \x. But not for variables, I think. Yeah, okay, never mind, that's not really important. So good, we have low positions, well, low and exit position. Then we have the amount of bytes and we have the algorithm, okay. Actually, the round decoding should be in this guy here though, like, yeah, let's put that here instead of in this function, in this class. So what should we, yeah, I'm going to leave this decoding out of it, but I'm going to just pass this byte array and the round number to the constructor of the round level. Let's put yeah, so I'm gonna transfer bytes here and I'm gonna put this in a function here. Well, I can do it in the constructor, right? That should be fine. That should still work. So we have our construction does the decoding. Is that good? I guess we want a constructor without a bytes thing though. So let's give it the ability to pass null to it. And then, yeah, so I think this is cleaner. Then we remove this from this decoding from the main class here and put it in Eggerland 1 round. That makes more sense, I think. And then, yeah, we dump below, but we decode here. And then, okay, let's look at the data length, which would be the bottom 7 bits, yes. So we're looking at bytes 5, and we add it with OX7F. And that's the algorithm. And well, no, that's the data length. So that's algo, and then that's the algorithm, and then length equals and the algorithm is bytes 5 and OX8 is the top bits. We're checking whether it equals OX80, of course, whether it's set or not. I guess I can just do this, and that would mean vertical or horizontal. Okay, let's see if that works. Okay, of course we're doing 8 here though. Right, so we're dumping this before our dump call. Right, that's fine. So round 8 has a vertical algorithm with a length of 73. Let's see if that's correct. So, well, I don't dump this here. Okay, I don't dump this information, but I'm sure it's correct. Let's see. Yeah, that's gonna be fine though. Then the next thing is depending on the algorithm, right? So if algorithm actually, well, no, it's fine. We can switch on strings. If algo equals horizontal, we need to store our blocks. So blocks equals, that's an array. Right, so what do we do here? Horizontal is the easiest, yeah. From top left to bottom right. We keep track of a block counter. That's to insert into the array. I think we can just do push though, so we don't really need to keep track of that. Then we keep the track of the index within the array. Okay. We extract the. We have to skip the first 6 bytes. Those are the header. Oh no. Because we're referencing data here. Right. No, that's not. Well, yeah, because we're doing bytes here. We have to do the same thing. Okay, sure. So let's just start looping. Let's see, byte index equals 0, byte index is smaller than the data length, and so we are looping here, and then the byte equals byte index plus 6. Okay. And then the repeat, and right, so we have our algorithm is comprised of simply the bottom 3 bits containing the amount, and then the value is in the other bits, right? The top 5 bits. Okay, so repeat count. I mean, I just can copy paste this, so it's easy as that. And then the block value is this. This would be, yeah, byte is correct. Okay. And then we just append the amount, right? Okay. So for let's I equals 0, I smaller to repeat count, and then this dot blocks push, and that would be the block value. Okay. Right, so we have now done the horizontal algorithm. Now let's do the vertical algorithm. That's this one. Okay, I mean, it should be quite similar, right? So we have a block index. Block index is used. Oh yeah, no. Now we have to keep track of which where in the array we are inserting, because we have to skip rows, right? Or skip columns, I guess. Do we assign? Yeah, we should. I think it's fill. Yeah. So we do a new array. Yeah. Okay. We have to do a new array because we need to assign the size, and that's 11 by 11, right? Now we can address in arbitrary positions, which is good. So blocks, yeah. So that's fine. Now let's keep a block index we have a column counter. Which we subtract. That's copied from the assembly or the disassembly from the ROM, I guess, that way of thinking. So we are doing, yeah, we're initializing 2 blocks per row, which is of course 11. And we're subtracting each time. And if it's 0, we subtract 120. Okay. First row, next column. Okay, yeah, sure. So blocks per row and per column, we better define though. Yeah, let's define that. Just so we don't have magic numbers. Blocks per column, okay. Now let's do the same thing. So we have a column counter. Blocks per row. Because yeah, we have to, every column is like there's, depending on how many rows, wait, blocks per row. Yeah, that makes sense, right? We look at the x-axis to see how many columns there are. And then we're doing the same thing as this. Yeah, so we're looping over the data length, right? That makes sense. That's just the same thing. Skipping the header, then repeat count and the block value is the exact same thing, right? 07 F8, yeah. So that's also the same thing. And then let's just copy this and convert it. Oops. Then I don't have to switch between things. So we are looping over a repeat count, and then that's going to be this dot blocks, and the block index is indeed our index here. The column counter is decreased, right? Because we're doing a column, an entire row at a time. I think plus equals work, right? Yeah, that works in JavaScript as well. And then if the column counter equals 0, we're subtracting 120 because we have to do the next one. Yeah. And this would be blocks per column, and this would be blocks per row. All right. I think that's it. And then we should have our bytes, or our blocks at least. I'm not going to dump them because we can just visualize them in the interface, of course. But yeah, that should be our array of blocks. Let's see what we have here now. Where is this stupid thing? New Eggerland level. So we dumped around. That's fine. We don't really have to do that anymore. We just can return this. So we decode it here. Okay, right. So we have a round. If round not equals null, then we can right, we're just copying this data, and that should be the exact same thing as round dot blocks, right? And that should work. Yep, it does. That's level 8. That's weird why that doesn't work, but am I missing, because we're loading level 8, right? I think I should remap that to 1, of course. These undefined. Let's reset that to 1 to 5. Yeah. So let's get rid of this. Okay, so we're at level 1, 2, 3, 4, 5. Okay, these are crashing. What's wrong? Okay, these are algorithm problems, I'm guessing. Current round number is undefined. That's weird. Okay, so we are extracting the wrong numbers apparently. So the bytes aren't exactly correct. Like it's trying to get a texture for a specific number. The numbers are defined here. These are the values that get read from the data that we just tried to parse. And apparently there's a different number in there that doesn't make it work. So there's an error here with our algorithm. Now we have to see which one it is, of course. I don't know why it starts at level 2 though. So round 1 works, 2 works, 3 doesn't. But it already crashes before we load here though. I guess it's doing all 5 yeah, at the same time. So let's see which algorithm is being used. Okay. Yeah, it's the horizontal one that has a bug in it. Vertical seems to work, and then horizontal, which is the easiest one. I don't know what I'm doing wrong here. Is it the push? Right. Am I pushing at... right. I think I'm pushing beyond 11 times 11 here, because I've already reserved 121 blocks here. Yeah, I think so. Yeah. Let's dump that. I think there are going to be 121 zeros at the start and only then the level. Yeah. I'm already seeing this. Yeah. Wait, why? Okay, empty slots and then a couple 8s. Yeah, no. That's weird though. Why would it be 8? 8 is walkable space. Yeah. No. That's correct. And the length is 242, which is 2 times 2. Okay, sure. Is 2 times 121. So I shouldn't use push. I should index with the block index here. So let's do this. And then I'm going to say block index plus plus equals block value. That should work now. It's to numeric block index is not a function. Weird. What? Block index. Can I not do that in one thing? Sure I can. This block index is not a function. Wait, why did I do it here? This dot blocks. Yeah, that's the same thing though. Oh, okay. That was stupid. Right, 1, 2, 3. Yeah, that works. Okay, so our parsing algorithm works now. Now I am curious why. I mean, we can remove this too, though. We don't really need a dump anymore. Right, I'm wondering though why I can't load. So this current round number equals 1. Right, that should be... Okay, so yeah. this should be kept from 1 to 5, and I wanted to do this, right? So let's say with the next 5, then I can do round 6, I guess. 7, 8. Yeah, 8 is the one with arrow, because you need to change the arrow power up here. Well, you use the power up to change the arrow. So that's 8, 9, and 10. Okay. Right. So I shouldn't have messed with the iteration, rather with this one here. Okay. So we have successfully decoded our rounds here. This is the algorithm that's important. What we can do now is use the power-up information to visualize below here. What we have to do is we have to make it so wait, let's go to construction mode here. Easier to just reset the machine, I guess, if I didn't press the wrong thing. Right, I don't need a keyboard because we need to go to power-ups. So we have 3 power-ups we can choose from. Well, 4 if you include no power-up. We have 3 power-ups with 4 options and an amount. The amount goes up to 63 based on the bit division of the storage of the power-up, meaning these guys here. So the top 2 bits is the type, and the bottom 6 bits are the amount of hard frame counters. So for 6 bits, that makes sense, right? We have 63 options. So if I access or toggle the bottom 6 bits, we have 3F, which is our 3F here. And those are 63 positions. Now, what's curious though, and that's interesting, is seeing as there are 121 positions here, you need low and you need an exit. So we have 119 positions left. You could potentially put 119 hard framers here, but you can only trigger power-ups up until 63 hard framers. But yeah, I mean, that's a little implementation detail that they didn't care enough about. Because yeah, why would that matter, right? You wouldn't make a level, I guess, filled with hard framers. I mean, you might, but so yeah, let's put the okay, stupid fly again. You could we can start with adding the power-ups though. So let's do that. Let's add some text here. So that's in our Chrome, I guess. So we have the walls and then initialize tools. Let's make an initialize power-ups. Let's put that below the tools here. Set current tool. Let's put it here. Let's see. We'll start with adding some text. And we will add that to, well, should we, yeah, let's make a container for the power-up stuff. So let's make a power-up container. And then this app stage append child, this power-up container. Okay, so we've added it. Now let's say this create text being power-ups. of size 16, and then let's add that. Add child. I don't know if you have to do append child or add child though. Let's see. Yeah, add child. Don't know if it makes that much of a difference, but yeah, that's fine. Caption, and let's set the position. To let's start at 0, 0, which is the center of the screen. All right, let's move it to the right. Well, that was 0.19, I think. To align it to the left side here, yes. And let's put it down a bit. 0.2 perhaps. I mean, let's do it singular. And let's put it slightly higher. Because I need the space though. Why is it not? Is it not getting higher? Yes, it is. Now I need 3 power-ups, so I need 3 selection thingies. I'm probably sure I'm gonna have to do a, well, no, I can click and cycle through them, I guess. And then the amount I need to, that's gonna be difficult because I don't have like an input I can use. Right, so let's just put 1, 2, and 3 on the stage. Let's give that 16 as well, sure. We have to distribute those though, but so let's start at 1.25 or 24 or something, and 0.17, and then 2 is a bit more. I don't know exactly where. That's fine. And then let's add all of these. Right. So the height is a bit off. Okay, that needs way more. And now let's spread them out a bit more. So yeah, that's 50. So let's do 25. 50 and 75. Right, that should be spread out. Yeah. Now let us add 3 textures containing the power-up visualizations, the types. So let's make a new animated sprite. Not that it has to be animated, but let me copy that. That's quicker. Power up 1. and let's default it to a selection rect. In other words, nothing. But I need to draw like a rectangle so people know that you have to click on that thing though. Let's position that as well. And let's just do that for now. Let's put it a bit down. But I have to center it, right? So let me first visualize it so I see what we're working with here. I need to set the size too, I guess. Well, no, apparently not. Oh, I need to set the scale though. So yeah, okay, so I need to do this. Well, no, let's pick it from somewhere else. Yeah, let's copy that. So we know how big to make them. And then I think I need to just do set scale, right? Yeah. Yeah, that's not going to change anything, I think, because yeah, that's pretty much the same thing. Okay, let's do this 3 times. I mean, I can like put this in a loop though. That would be the better way to do this, but it's fine. Let's first see what we get here. Yeah, I'm gonna have to do this in a loop, obviously. Right, and then 50 and 75, that should put them right. All right. It sucks that it does the not anti-aliasing, but like the single pixel width thing depending on the width of the window. Maybe I can fix that with a shader that puts some CRT lines over it, so you don't really see it. Now, question is, do I prefer to put the amount to the right of the boxes? Because we're wasting a bit of space here though. Let's just make this function first and then position it where we want. So what do I need to do? I need to make it clickable. I need to make it clickable. I need to add the hardframer count to it. Yeah, and that's it, right? I just need some space for some buttons. I need an import button, an export button, a clear button, and that's it, I guess. So yeah, I do have space left though. I mean, at the end, I can still space things out to make it seem more filled up, because I don't want to like an empty space at the bottom here. Yeah. All right, so let's make this clickable and let's make this cycle through all the potential power-ups. Yeah, so it's this one. Oops. No, it's just this I need. So on pointer down, we let's see, I might need this function elsewhere, because I need to initialize, when we load the level, we need to set the power up as well, right? So I can't just, although that's not a pointer down thing though. So maybe I can just put the function here and Yeah, so yeah, let's just save a state. And I need to save this for every level though. So construction board data, I'm gonna rename this to just data, right? Because this is all construction board stuff. So here we have an array of 5 sets of data. For every round, we have a set of data. We need now the same thing for 5 sets of 3 power-ups, right? So if I do power-up data equals this, actually, why do I not, like, I initialize this somewhere. Yeah, like right here in initialize construction board. I need to do the same thing here, right? And I fill this with vocal space, but that's fine. I can just fill it with none, I guess, which is also 0. Yeah, so this is an initialized function. Do we have an initialized function? It's in initialized Chrome, but yeah, of course we have initialized. Okay, so we can put it here. So before we do all this, let's initialize our power-up data. So we have an array of 5 for our 5 rounds, and then we make a new array of 3 entries. And wait, well, you need to do a combination of things though. So we have an array of 3 things, but they aren't just filled with 0. They have to contain the ID and the hard framer count. So I can put in a little object, I guess. Can I fill this with an object though? I'm not sure if that's possible. ID and hard framer count. Does this work? I mean, it's not complaining about it. Yeah, apparently it does. So let's log this. Let's see if it's actually doing what I wanted to do. Yeah, it looks like. So yes, that's perfect. Okay, so we have an ID, a power-up ID, and a hard framer count, which is all we need to store, right? So now let's put this in a loop though. I guess I can put this in the same loop. Yeah, so okay, for let I well, let's power up counter equals 1, smaller than 4, power up counter. Okay, and then we have so const power up counter text equals this create text. I just can do power up counter here, right? 16 size. Can I do to string? I guess I can. I should, I guess. Now we just have to keep track of our positions though. So 0.255 and 75. So let's start at 0.25 and just increment or add 0.25 every time we loop. So X offset, and that is our standard Y offset. That's fine. So we did 1, 2, 3, and we just have to add it. Okay. So that's this. And then we need to initialize the sprites themselves. Power up sprite starts with a selection rectangle. Let's change the name of these guys. Yeah, same thing, X offset. and at 35 we're setting the scale that we're going to look at later, and we just have to comment this out, and then we increment our X offset with 0.25, where for 86, what's wrong? Oh, did I? Okay, I have to exit or close the for loop, I guess. This power-up container add child. Why not? What? It's a new container. I'm adding the caption, and I'm adding the counter text and the power-up sprite. What the fuck? (444). This power-up container child is not a function. What? Why would that not be a what? That's so crazy. And now we have 451, so there's this one. Why is that not available? What? That's crazy. Okay, I'm doing something stupid here because that's the exact same thing though. I mean, this one works. Why would the other one not work? Is it because this is wrong? Yeah, that's fine, no? Wait, so is it the third one perhaps? 1, 2, 3. So yeah, it does too, but not the third. Okay, I'm doing something very stupid. Oh, wait. Of course. Okay, so we have the same thing now in the loop. That's much better, of course. Now let's look at our cycling function. Wait, so all we have to do is increment the power-up data here, well, the ID here, right? So we need to know, yeah, we do have access to power-up counter in this closure here, in this little lambda. We need to increment and like go back to 0 if it's higher than 3. That does make sense. Right. Okay, so do I have access to power-up counter? I think I do. I need the current value, which is this power-up data power-up counter ID, which should be 0, right? If I click it, yeah. Oh, that's undefined. Power-up counter. This power-up data power-up counter should be. Oh, that's 1. Yeah, that needs to be 0 based though. Okay, it's not logging anything. Oh yeah, I have to click. So 0 is still undefined. So this power-up data. Okay, do I do dot ID here? is it undefined? Let's just remove the ID then. That shouldn't give me the little object though. Oh no, it gives me, wait, it gives me everything. So this power up data is an, oh yeah, of course, we need to do the round number. Yeah, of course. We need the current round number. Yeah, this one here. We need to do this first, and then the power up counter, and then we have the ID. Yeah, that's better. Okay, and that's 1 and that's 2, right? So this power up data current round number power thing plus ID plus plus, and then if this equals is bigger than 3, then this equals 0. Right, so we're cutting off after 3. So 1, okay, I'm not dumping anything anymore. However, we need an update function, I guess. Well, I guess I can put it in this one though. Or should, well, no, I need the function separately because I want to call this when we load the level, so it updates to the correct thing too. So let's make an update function. We're going to do this 3 times. Power up counter equals 1. No, let's do it from 0. Let's just do I. And then, so yeah, we have to set both the count and the texture here. So the power up equals this, and we want I here, right? So we're getting the current round number and I. So we have our little object that we can inspect the ID and the hard framer count. Let's see. We're gonna switch on the ID. If it's 0, we need to access the power up animated sprites though, so I need to save those too, because I need to access them here. So these guys, yeah, let's save those as well. Actually, I mean, I can assign an array here, that doesn't really matter though. But in the initialize power-ups here, let's do an array of 3, and then we will override yeah. So let's do this, and then all right. So now we have them saved, right? So I can access them here, and I need to access them also. This becomes -1 then. because we're 0 based in that array. Wait, actually, am I always doing -1 here? I think I am, except for here. Yeah, so let's just, I mean, it's a bit silly, right? It's just for the text. Okay, let's do 0 to 3. Let's not do -1. Also, let's just do a template string here and do this. Okay. So here, these guys are all straight. Okay. Right, so we have the sprites now. We just have to update the texture. I think it's just texture. Textures equals, okay, so let's copy this. Update power-ups. This spreadsheet animation, so it becomes selection rect for 0. Okay, and I'm not going to do the hard frame account yet. 1, 2, and 3. Actually, I mean, well, that doesn't matter. These are magic numbers, but sure, I guess. Let's see at the definitions here. What is a bridge? 1. So this becomes actually I should load it. Okay, no, not that. Yeah, this cell to texture. Where are we? Okay, here. Bridge. What is it? Horizontal or vertical? I have to go look. Let's keep that the same. It's a vertical bridge, right? And then 2 equals arrow. Which one? Up, I think it was. Up, yes. And then this one is Emerald Framer. Okay, does this work? Update power-ups we have to call though. So we are, yeah, after our toggling, we have to call this. Let's see if it works. It does not. Update, okay, this one, okay, sure. Okay, it's doing all of them. That's not what I wanted, but, and then it doesn't go back. Why are we not going back? If it's bigger than 3, then it's 0 again. Oh, do I need, I mean the plus does work though. Power up counter, why does that not? Do I need to reference this here? Actually, let me dump all the power-up data. so I can see what is going on here before we, well, actually, let's put it here. Oh, right. No, yeah, no. I only need to do this. Wait, let's see if I'm updating or I'm visualizing incorrectly. So for levels round 0, okay, we have that doesn't make sense. Yeah, I'm already doing the wrong round number because I'm in round 1, which should be 0 then. Well, this current round number minus 1, of course, right? Yeah, that's 1 based, and yeah, that's 1 based, and I need to do 0. Well, I need to do one moment. Okay. So in construction board data, I'm using 1 based apparently, but for the power up data, it's 0 based, right? So I need to. It's not ideal, but yeah, I need to do that correctly. So that should at least put it in the 0 index, as in the first. So I have 5 rounds here. The first one is now updated to 111. Okay, that's already incorrect because I only clicked the one. So it is visualizing correctly, but these two should be 0 here, 1 and 2. So what am I doing wrong here? So the pointer down of this particular sprite does that not work the way I think it does? Wait, do I need to do a target or something? Do I need to update it on the target perhaps? Yeah, I think so. Right, and let's put a variable stating power up ID equals power up counter, and then I can access this here. Zero, 1, and 2. Okay, that makes better sense. And then I can just do that here, right? No, crap. Stupid JavaScript. Always something. It's looping it 3 times. I don't know why. So I click once and it's only calling this one once, right? So this body also gets executed once. Yet, if I go look, they're all 1. Is this the same reference perhaps? Surely that couldn't be the case, right? Is that fill like, are these like pointers to the same thing? or are they? Changes all elements within a range of indices in an array to a static value. Okay, is it a static value? Okay, I guess it is then. Okay. Do I really need to do that? Wait, so yeah, let's explicitly make this do it like this. Maybe now they're not the same. Event target power up ID. Oh no, I need to do this. Like this. Well, no, I can push 3 times though, but it just does, yeah, that does work. I can just do this, and then do this. Okay. Okay, but okay, the looping doesn't really work, but that's better than it was. So if it's over 3, then it should be 0 though. Why does that not work? Uh, 0 to 1 to 2 to 3, and that doesn't work. Okay. 1, 2, 3, 4. Just keep going. Oh wait, I need to set the ID though. Yeah, I think that's it. Yeah, of course. Okay, so now I can cycle through all the power-ups. Okay, that's what we want. And now the difficult part is going to do the hard framer count. I guess I can just do an input, a JavaScript input, and enter a number. That's going to be the easiest thing, I guess. Because I don't know, I mean, it's a bit of work to do that completely visually. Like in the game itself, they just do this with moving, like you select a wait, are we like here with shift, no, with a regular mouse, and you select one and then shift to the right and to the left, but I can't really do that in the game. Like no. Also, the number has to be between 0 and the amount of hard framers in the game, right? So there's 1, 2, 3, 4, 5, 6. So you can a maximum of 6. I'm just going to do an input, I think. Okay, let's start with putting these numbers putting the blocks and the numbers on the same line. Yeah, so the X offset is 25. We're going to deviate from that. We're taking that as a like margin thing, I guess. And we're going to subtract here though. So X offset minus 0.10, for example. Let's see if that ends up to the left of the blocks. Yeah, way too much. Why does my one look? Oh no, it's not cut off. Okay, so and let's use the Y offset here too. Okay, so that's 1, 2, and 3 now next to each other. That's a bit better. Let's give that a bit more room below the title. Okay. So now we have our power-ups here, and I think we still have room to put our, maybe I can put them underneath. I guess I should, because we don't need that much space anymore, just for a couple buttons. We do need space for the buttons, and we do need space for warnings. Like if you're missing Lolo or an exit, then it has to complain that you can't save the level, because you need an exit in the level to save it. I think I'm going to add a little heart framer logo next to the thing, so it makes it more clear that you have to that's what that number means. Because if you look at the game, it doesn't give you any indication what this number actually means, right? So let's see. Yeah, I'm going to add the little heart framer first. So I'm going to need a new sprite. I don't think we need to access that sprite. Yeah, first thing I was, I was thinking about changing the pointer, the cursor though. Yeah, that's just this. That's on this one, right? Yeah, okay, we have an appropriate cursor. Now just add heart framer. And this is going to be what was the function name again? I forgot. It's here, cell to texture. This cell heart framer, normal, right? Okay. Where are we going to put this? I have to scale it down. Let's take half of our regular scale. And let's position it to our X offset. Yeah, let's put it underneath the number. And then the Y offset is it overlapping now? I think it will be overlapping at the top, so we have to add the cell size, but let's just try it first without doing that. And then we have to add it to the container. Let's see. Filter texture is not a function. Yes, it is. Oh yeah, it isn't. It isn't. Wait. It's an array. All right. That's quite big. Well, I mean, wait. I'm dividing by 2. Do I need to invert that? That's weird. Oh no, it's not a cell size. Wait. This is scaling over 2. Right. So we have small things now. We just need to push them down. Yeah, the position, the Y offset needs to come down by a bit. Let's see how far. Well, I mean, it's going to be the cell. Well, that's way too big, of course. But that doesn't really matter. Maybe 18 perhaps. A little bit more. Okay, and now we can add our number to the right of that. I can do it in a smaller font as well, and we just have to make that clickable, and then we're asking for an input number. So let's now add that. So I need to save this one too because it has to be clickable, and well, although maybe not. Why did I? Yeah, I needed this one to be addressable in the update function, but yes, this text thing has to be addressable too. So I need to save that one too. Let's just first add it. So let's add, well, it's a new text, right? Art framer count equals this create text. We're starting with 0, 0. Add font size. Let's do it a bit smaller. Well, let's start with 12. Let's see where we go. We're updating the position to so X offset then, right, it's going to be a little bit more to the right, I think, and Y plus 0.19. Of course, we have to add it, of course, or we won't see it. Right, that's too small. I guess I can do the 16, the standard size. Maybe that thing slightly smaller. I mean, it's getting a bit squished. But yeah, I'm trying to make it the same size though, like aesthetically will be a bit more pleasing, I guess. Why is it not coming down in size? Okay, that looks a bit better. I'm going to give it 45. Yeah, that looks similar. I think we can go to the right a bit though. Yeah, let's move that a bit to the right so it's a bit more centered. Where are we? X offset, let's start there. That's too much. I did the wrong direction. Wait, so X offset minus, wait, why? Okay, so this is I need to go to the left, so I need to go closer to 0, meaning why are you going to the right? That's insane. Yeah. Oh, wait, no. Wait, that doesn't make sense to me. What am I looking at here? So X offset is indeed this. And the text is at minus 0.05. Oh, I was looking at the second one, I think. Yeah, I think I was looking at the second one. Like there was one here too. Yeah. So, but not as much though. Right, let's now pull in the thing here. A little bit more. So we're going to do 08 here. And I pull this one a little bit more. Okay, does this look reasonable? Not entirely satisfied with that lineup, but I guess it's good now. Yeah, yeah, I think that's fine. At least now you have an indication that it's hard framer count. Well, I mean it's next to it, right? So let's make that clickable. The hard framer count at least. I need to save these though. Okay, I need to make these static, I guess. Yeah, this one too. Right, so now these are, at least have the cursor at least. Let's see, now I need to save these hard framer counts in the object. Power up sprites, power up hard framer counts, sprites. And let's get 3 of those too. Wait, no. Why did I get 3 there? Oh yeah, no. We don't have to save this per round because we only have 3 on the screen. Okay. Wait, am I doing... Yeah, I'm just assigning. Okay. So it's this that I have to do instead of this. Yeah. Right, so now we have them. Where are they? Did I do the wrong thing? I did the wrong thing. Not sprites, but this guy here. Okay, so now I have the hard framer count sprites saved, so I can address them in the update function, which we need to do if we want to update the values, right? Let's first ask for the input on the pointer down thing. So this one, pointer down. So what was that again? and the default is 0. Does this work? No. Input is not defined. Wait, is that not... No, not an input element. What is this? Alert and... No, prompt. It was prompt, right. That's been a while since I've used this. Message and default value. Yeah, that's what I wanted. I mean, aesthetically, it's not the best though, but sure. So please specify the amount of hard frames that need to be picked up for this power-up to become available. Okay, so we enter a value, we get the value, we're doing a parse int on that, of course. Value string, if value not equals not a number, then we have to mark max, I guess, of right. I don't have a count of, yeah, so that's that later. Plan to max amount of hard framers in the level, just like the game does itself. So if it's not a number, okay, so we have an actual value. Let's not deal with negative values. Yeah, and also have to clamp it to 63. Right, because that's the max. And now we just have to update it or write it to our thing here, which is this. So we're in power up data, current round number -1, this power up ID, and then this is HFC, I think it was, equals value. Okay, so now we're storing the value at least. If I do 554 here, sure, okay, we're invalid. Okay, sure, that's not a const. Why does this not know about? Wait, oh, okay, we have event as a parameter here. Oh, we do though. Oh yeah, no, we have to assign the power up ID to this guy too. We need to know the power up counter. Yeah, we need to know which one it is, which one of the three. Right, so we have now 50 in our thing, and we just need to update as well. And now we can say here, this power up hard framer count sprites. Oh, I need to replace this one though. Yeah, because we need to throw this texture out and create a new one with the correct number, which was done simply here, right? How do we do padding of zeros, pad start? I mean, it is literally a function for, okay, sure. Number to string pad start 0. Okay, that's what we need. Create text of font size 16 with number being the one we so power up is ID and HFC no, wait, what? No, that's power up dot HFC. Yeah, no, so it's this power up dot HFC. the string path start. Yeah, okay. So wait, no, we don't need to do this just in case of 0. We need to do this every time for every power up. Okay. That's not in the switch statement. So 50. Okay, that doesn't work. Wait. Yeah, I need to remove it, right? I just can't update the array. I need to remove this from the stage, and so crap. I need to oh shit, how do I do that? Because I need to do this entire thing again, right? Because I'm making a new one. So what did create text to? Can I not replace the yeah, that's I mean, can I not just change the text? The text. Can I change this? Let's see. That would be the easiest thing though. Then I just have to do this. Does this work? Let's see. Yes, it does. Perfect. So yeah, I can change these values. I can't go over 63. Yeah, perfect. I can't go negative. Doesn't work that way. Okay. And now we need to clamp to 6, of course, because there's 6 hard framers in the level, but sure. So that works too. Yeah. Okay, let's commit this. Well, I need to do one thing though. I need, when I'm loading level 8, I need to update it. Yeah. So let's load level 8, because that one actually has a power up in the level definition. So let's add 5 here. So we load the next 5 levels. This one needs to visualize. So this level has an arrow power up. We need to visualize those though. We need to visualize that. So let's see. We're doing the fetch, which then goes and sets the construction board data to the blocks, but not the power-ups. Okay. So that's this. Yeah, okay. So now we need to check if around power-up 1 type isn't around power-up none. So we do have a power-up here. Then we need to just update the data. We don't need to do something visual. We just need to store these guys, right? Power-up data. Yeah, we need to access power-up data. For current round number being round number -1, because we're 0 based in our power-up data, then we need to index 0 because we're talking about power-up 1. I'm gonna have to, like, because these power-ups aren't in an array, I'm gonna have to write them out. That's a bit silly, but I mean, I guess I can fix that though. That should be fixed. So let's start, but let's do it first manually. So, and then the ID equals round power-up 1 type. I think that should be it, right? and then we just need to update power-ups at the end. So I think this should now become a arrow in round 3. No, it's okay, what? This power-up data round number -1. Oh, no, round number is 8 or something. Yeah, no, I need to know. No, this is current round number -1, I think. Yeah. It's this round number here. Okay, so it's not doing it. Okay, so 2 and 1. Wait, why is it doing 2 and 1 for this? Oh, does this one have an update? Surely not, right? This doesn't have a power up. Round 6. No, round 6 doesn't have a power up. So why is it already? Well, I guess it's loading all 5 levels, right? So we're doing this fetch. Yeah, okay, we're doing this fetch immediately. So that means we don't have to do this here. We need to do this in the... Oh, right. We need to do this when we're changing levels here. Yeah. So yeah. So we're decoding and we are inserting this. Wait, let me think here. So this function is called 5 times at the start of the thing. And yeah, we are addressing current round number because that gets updated, right? Yeah. So we are assigning current round number here. So we do know, yeah, we're starting from 1. And okay, that's good. So this is at least correct. But surely this is what we need to do though. Like, wait, so let's dump it. So yeah, we had a 2 and a 1 here. These are in these 5 levels, level 6 through 10. There are 2 levels with power-ups, sure. And arrow should be the first one. What was arrow? Arrow is 2. Yeah. So okay, that's correct. So the first one we encounter is for level 8, which is an arrow, which is this level here. So we are actually setting it though. So let's now see if this power-up data information is correct. Yeah, so we're doing this 5 times, and at the end, for level 2 here, yeah, that's correct though. It did put the 2 in there. So okay, I'm stuck. Let's put the HFC, the hard frame count, in there too. Okay, so yeah, this is correct. The update should only happen, right. I should not call this 5 times because it's doing the last one. So I'm doing them for all 5, and the last one happens, and this doesn't have power up. That's why it's not updating. So actually, I should do this after I select round number 1, and this selection function, this one should do this. Right. This should update the power-ups, not this one. Yeah. So every time I'm changing the current round number, I need to update the power-ups. That does make more sense. Yeah, there's no power-ups here, no here, and now we have 8 hard framers, 1, 2, 3, 4, 5, 6, 7, 8. So all of them, and then you get a power-up. So that works. And this one, 3, and that's correct too. So that would mean level 9 has a power-up too, right? Oh, it has 2 bridges though. Why does it not? Oh yeah, of course. Of course. I only did 1. So should I change this to an array here? I think I should. Yeah, because that's the only reason. Oh, yeah. I need to put this in an array so I can loop better. Power up types is new array 3, and power up heart frame counts is new array 3, and then I can just do this, I guess. Right. And then right, that makes sense, right? Now they are in an array, and I can just assign them. Why are you complaining here? Because of these guys. Okay, sure. And then I need to change this to a little array. Yeah. Okay, and then we can do this. Yeah, if it's not, actually that would be 0 though. I don't really do the check here actually, because it's going to be 0, 0 for both. So power up data, right, is power up types I, and that's power up heart rate counts I. Right, so now I'm doing all 3, and this doesn't work anymore. Oh yeah. I need to do. Wait. Yeah. Also there. Yeah, that works. And this has 2 bridges now. 3 and 5. 3 and 5. Okay. And then the next level is. Okay, I didn't filter here. Around 22. Let's load around 22. Let's add. Well, let's add 22 because we're starting. No, we're starting at 0 at 1. So let's round. Yeah. An emerald framer with 6 heart framers. Yes, that's round 22. Okay. Right. So now we are loading our power-ups from disk. Wait, let me see one more thing here. I do want to fill that in with 8 though. Yeah, let's query that value. Update power-ups. No, it's in this prompt thing here that we need to be. Let's see. That would be this though. So that should show me 8. Yes, it does. Okay, and now the last thing with concerning the power-ups is we need to count the amount of heart framers in the level and clamp to that number. Okay, that can be done in the round, I guess. We don't have access to the round though. I guess I have to make that a function of the construction board rather than the round, because we're not saving the round, which we should actually, but sure. Yeah, we need to call a function here that counts the amount of hard framers in the level. But I can write a simple function that just does that. We need to go look at this construction board data of the current round number, which is 1 based. Yeah, I mean, that does suck that I did do it like that, but there's one thing that's 1 based, but I mean, it's fine, I guess. Where do I new array of 5? But it's 5 though. Why is it 1 based? No, it's not 1 based. It's 0 based. Oh, but current round number is 0 based. Yeah, I think so. Well, no, because I'm painting it red if it's equal. Yeah, that's 1 based. So that's 1 based, and I'm assigning it to current. So current round number is 1 based. But how can this then work if I... This is wrong, right? How can this work? Because what I think is happening is I'm actually doing this 1 based, but like when initializing, I'm initializing an array of 5, and I think I'm just adding a 6th one whilst loading the data now. Because yeah, I'm just filling these guys, but let me see what that contains after loading the default levels here. So yeah, let's dump that out. I think there's going to be 6 entries in there. Yeah. And what's weird though is, so we have 6 values and they're all filled in. Oh wait, no, the 0 one is just walkable space. Okay. So the 0th one is empty. Okay, so this actually should be this should be 6. And we're filling, yeah, we're filling 6 boards with walkable space, but we're never using the 0 one. Fine, I guess. Okay, where were we? I was making a little function which I've completely forgotten now. Here, current hard framer count. Okay, so we are addressing the current round number, that's fine. It's 1 based. And we want, these are the blocks, right? And let's query this when we click on the thing here on the prompt. Yeah, so this is our array of 121. We just need to count the amount of heart framers. Can we do that with reduce? I always forget this stuff. With filter, I guess, and maybe we can just do filter and do a count. Can I reduce by accumulating this simply? Let's see. I don't really use these map filter reduce things often to know this by heart, but let's see. Filter that should become I equals. That's how that works, right? Oh no, yeah, it's like that. And what's the number? I guess it's this cell heart framer, or I equals this cell heart framer with bullets. Right, those are them. Yeah, okay. And can we reduce this then? Callback function. Let's see how we do this. Accumulator and current value. No, let's just do length. That's because that's all we need. Yeah. Let's give us some more space here because I'm gonna add this information. Okay. And then value is the max of value and heart framer count in level, right? So you can't go above that. Let's see if that works. So we have 8. There are currently 8 heart framers in the level. Okay, ignore my value. Sure. Well, it's the not the max, of course. It's the lesser of the two. That makes sense. Right. So we're clamping at 8. That's very good. Okay. I think that's everything with power-ups we need to do. Yeah. Let's commit this. So yeah, we remove this, but that's okay. So having trouble with that. Yeah, that's fine. And we parsed the level. We added the power-up stuff. Yeah, that's all we did, right? Yeah. And we visualize the power-ups. All right, so now we need a couple buttons. Oh, we still need to limit the amount of enemies you can place, because there's limits on that too. You can do 10 Medusas, 10 skulls, 5 almas, 10 snakies, and I think 10 goals. Yeah. Let's do a clear button first so I can easily clear a level. Otherwise I have to like click all that stuff. That's not good. Right. Let's add that to the Chrome. Okay, let's add a button. Let's it was 0.19, I think. I should have put that in a variable though. Power up is at 0.19, and let's get a button container too. So 0.19 is the left margin here. Let's go, it's going to be clear almost at 9 though. Let's put it at 8. And then let's say this button container equals new pixie container. And then we can add this to the button container. That's clear button. And then this app stage, add child, this button container. Okay, so everything's added. Let's see where that ends up. Okay, that's way too big. I mean, it's a bit difficult though. I need a clear import export. I think that's all I need, right? I also don't have like button Chrome, so it's not obvious that it's a button. I guess it would be if import and export are in there too. Okay, I'm going to add a line beneath the power-up stuff. And where are we at? That's Exxon. Well, I mean, I guess I can use Y offset. It has to be lower though. No. way too much. Okay. Yeah, I can just space these out a bit. We need a clear button and a import and export button. And then that will be a bit better spaced. Right, I think that's all I need though. I need to clear the level easily. I need to import a standard level or a custom level. And I need to export the disk. I guess for export I need multiple options. But I can't do that in a pop-up or something. Like where are you going to export to? I mean, the first thing I'm going to offer is a simple disk export, right? Like a file export, I guess, which you then have to put on a disk image, which you can read into the emulator. But yeah, I don't think I need something else though. Yeah, and I have some room for the error messages. Yeah. Okay, let's see. Clear should be easy though. That shouldn't be a big deal. Let's see, event mode static, and okay, so we need to copy this stuff. And what do we do for clearing? So we have the board data for this current round number equals new array. This, do I have, wait, do I have, so I'm assigning around blocks, but I have a function where I initialize this stuff though. Yeah, so it's a new, yeah, this is what I need. And this becomes, instead of I, becomes this. Fill it with walkable space. And then we need to call an update. Right. And then, yeah, I think that's it. Yes, that works. Should I do a, yeah, I think I'm better doing a question. Are you sure you want to clear? Because that's a bit permanent. Let's see. pretty much done, right? Yeah. Oh, this should clear too. Power up data of this current round number. Yeah, it sucks that because now I have to do zero based for this round, and we need to do this 3 times. I.id equals 0 and HFC also 0. So clear, yes. Of course, we need to update power-ups. Clear, yes. Okay, that's good. Clear, yes. That's all we need to clear, I think, right? Yeah. Okay. Let's commit that separately. All right. And now our import, that's going to be simple at first. We just need to choose out of the 100 basic levels the 5 extra levels, or the 10 bonus level, or the 15 or 20 bonus levels. 20, I think there are. Yeah, every 5 levels there's a bonus level, so there's 100 levels, so 20. I'm not visualizing them though. I'm just going to do them numerically. Like, yeah, I'm not going to visualize the actual map of the level. I'm going to do that elsewhere. Right, I'm going to need like 5 minutes break, but I will be back in a bit. All right. Let's see. So import would imply showing a pop-up, I think, a graphical pop-up. So let's see how easy that is. Actually, we should dim the background too, but I don't know really how to do that. Let us first create a pop-up and just show it. It's not really part of the Chrome, I guess, but yeah, that doesn't really matter. So let's start doing that. Well, we have to have a container. New Pixie container, and we're adding this to the stage. Okay. Right, so we have our container. Let's, I'm gonna have to draw the little wall brick thing around it, I guess. But let's now just position it. Like, if I don't add anything to it, it won't show anything, right? So I need to, how do I add like a black background to that? I don't really know how to do that because I don't know Pixie well enough. Position set. First, let's determine the width and the height. Let's put it at 50% or something. Wait, let me think, because I can't use the convert function though. If I use, wait, so it's from -1 to +1, so there's 2. If I make this 1, 1, what does that give me size-wise? $365, 205. Does that, no, I need a ruler. Does that effectively, hi Kimberly, I'm working on reproducing the construction mode in the game, like in the whole game this year, where you can make your own levels. I'm making that online, like making the, giving the ability to create a level online instead of having to do it in the game. That's what we're working on right now. Yeah, that's not enough. 365 pixels is like here. Why is that so small? Wait, no. So I need to do, I need to go for 0, 0 is in the center, right? So I need, if I need half, that's 0, right? Right. So I think it's 0, 0 I need to do. Then I have a rectangle that is, or a width and a height that is half the dimensions of the canvas, I think. So, no, that's even less. Why is 0, 0, 182 though? That doesn't make sense. Because the total width is... Oh, but we're in... I've zoomed my Firefox in. So 1465 becomes 700, I guess. But that's still not... That's still not enough. Wait. Wait, let me put on the thing here, where is it? The position grid. Okay, I should do that at the end, of course. Okay, it's still underneath, sure. Right, so 0, 0 is here. If I can actually go from negative. Yeah, let's do that. That's easier. So from negative 0.5 to plus 0.5 in both directions. That should just give us a rectangle. Yeah, that should be big enough. Okay. So if we go from negative 0.5 to plus 0.5, then we have from 91. Why is it so low though? 91. It doesn't make sense to me. Well, let's see where it ends up, right? Can I do this? Well, no, I need to do this, and then can I do width? I need to do pixie container because I don't know how that works exactly. So position and then scale. I guess it's not a container I'm looking for then. It also adds built-in support for advanced running features like masking and filtering. I guess it's not that what I'm looking for. I think I have to do a graphics then to just do, yeah. I've done that before with the lines. Just paint a rectangle black. That's what I'm probably gonna have to do. No. I don't want this search. Pixie graphics. Oops. Yeah, this is what I need. So I'm going to retain the container, that's fine, but I'm going to add a rect. And I did already use Pixie graphics, so I can just steal this information here. Well, I mean, it's not, it's simple as that, of course. So I don't need to change anything here. And then this pop-up import container add child rect. And then we can add a rectangle. And then now I have to think though. Okay, let's try spreading from -0.5 to, can I do two spreads here? Not sure if that will work. To 0.5.5. Yeah, it doesn't do two. Oh, it's okay. No, I need an extra dot here. Okay, does it work? Does this work? Let's see. Yes, it does, but it's underneath because I'm painting the, oh crap, I'm painting the container. I'm painting this last, I think. Yeah, I'm messing with order. So, oh yeah, the width is not, so it's not an XY for the second one. It's a width. So we need not 0.5, but so this goes from, I want the one from -0.5 to 0.5. That's one width, right? Which is half of the thing. Wait, let's see. Yeah, but if I do 1, it's even bigger though. Yeah. I can't use this. I can't. It's not a coordinate, right? It's a dimension. It's actually going to be yeah, that's what I wanted. But on the top, so I have to mess with my rendering order. Can I manipulate that? Okay, that's a different thing here without changing the scene graph. So it's based on first come, first serve, I guess, like who gets added first, which just implies that I have to add this one last though. Can I do this? So I'm doing this in Chrome. Yeah. I'm doing this in Chrome and I shouldn't. So let me extract this one here and then do this after. Does it come on top now? Yes, it does. Okay, that took some thinking here. Also, I don't want it black. I want it this gray background, but sure. I also don't know if that's going to be enough space, though. Oh, and this shit is still clickable, of course. Okay, that's not good. Okay, let us add some stuff to this. It's not import, it's what was I doing? I was setting the position of the title. For the pixels, let's set it at the center first. And let's see what that does. Nothing, because I didn't add it to the container. Okay, let's move that. So that's going to be 0.5 and a bit, right? 0.5, no, negative 0.52 for the X, a little bit more. Oh, no, other direction, 48, yeah, for other direction, of course. And then we are at the same distance vertically, I guess. A bit more or less in this case. Okay. I guess I will do default and just do all the numbers from 0 or from 1 to 100. Yeah, that's going to be the easiest right now. So I'm going to do a section the same X, but a bit lower. That's too much, probably not enough. Okay, now let's see how this works out. I have to do this for 100 times. Current X equals, well, let's start X equal negative 0.48. That's where we start every time. And is start X, okay, that's a const, and then let current Y equals negative 0.3. Let's start at negative 0.2. That's probably not going to be enough. And then round number is going to be the text. I'm going to do pad start again. This guy here. Is I to string pad start with a 0. Add size 14. And I'm going to position this at current X, current Y. And I'm going to increment current X. So we're going to put them all on the same row for now, and then put them on different rows next. And we're going to add an arbitrary number here to see how that looks, right? Okay, that's not enough increment. That might be too much, but we need to move the font down a bit though. Oops. Make it slightly smaller. That gives us 10. So that would be 10 rows though. I have to go even smaller, I think. Right, and I can remove a bit from the spacing. Right, now let's give it an indent. Okay. And let's cut it off at 10. If that happens, current x equals start x and current y as an arbitrary increment as well. Of course, we need to cut at 11. Wait. Yeah, no, that's always this crap. Okay, let me think about that later. That's fine. Yeah, we're not gonna have enough space though. So we need to make it bigger. That's fine. Oh, it's because we're starting at 1, right? Of course. I modulo 10. Okay, so if I minus 1 modulo 10, it's like this, right? Yeah. But we need to make it bigger and a little bit higher up. So we are starting a little bit higher. No, 25, that's going to be too high, I think. Oh no. Right. Now let's keep our x and y over this too though. So we know because I'm gonna make the rectangle bigger now, so we need to keep track of this better. So I'm gonna say current y over here, and I'm going to just subtract from current y, or add, I guess. So current y starts at negative 0.5, right, which is half of this quadrant. And I'm going to make this 75. That might be too big though. Like, let's put it as 6. Current y. And then I'm going to subtract some 0.05, which is the difference between what it was. I guess it's plus here. So we went from 0.5 to 0.45. So that should still be the same offset. And then we went from 0.45 to 0.3. So we're subtracting or adding 0.15, I guess. Okay, and then this one, I already forgot the number, but that's fine. We can just add a value and see where we end up. Okay, we didn't change the rectangle. So x is minus 0.5, that's fine. This is current y though. Is this not I don't know, it is higher. I guess the height is just not adjusted. So the height, where is the height? Okay, the height is, it's not the height minus 2 though. It's, well, this sucks because now I can't use. So wait, if it's at 0.75, that means it's a quarter, right? it's a quarter from the top. Yeah, 75, 50, 25, and 0 is the center point, so that's a quarter from the top. So all we need to do is the height is this times 75, right? I think that's correct. Yeah, it is. Okay, so this margin is too much. Is it this one here? Yes. I might need more space though, because yeah. I need regular rounds, extra rounds, and bonus rounds. Let me look at the game and see how they call that. I have the original game here with the manual. And let's see what they call that. Bonus stage is what they call. I mean, they use a different names too, though. And this thing is filled with. This is like the manual from the 80s. This thing is filled with spelling mistakes. What is a bonus stage? So they call it bonus stage at least. And a special round. Okay, they call it special round. What a special round appears if round 100 is finished, including particularly difficult 5 rounds. To advance to the special round, you must enter a special password composed of 10 characters. We know that, yes. So they call it a special round. Okay. And that's this one then. Special rounds. And let's give it some margin too. That might be a bit too much. And there are 5 special rounds, right? So if you go look at the rounds here, so round 22. So we have round 100, special round 101, 2, 3, 4, 5. Yeah. And then we have bonus rounds, 20, I guess. Yeah. So 5 special rounds. We just need current X to be reset. And we do this 5 times without any flipping of Y. I is smaller or equal than 5. And then we will add another round number. Yeah, I think that's correct. It is not, because I didn't add any Y. Five rounds here. And then bonus round. What do they call it? Bonus stage? Bonus round. Yeah, okay, they call this bonus stage then. Okay, sure. Like they call it round everywhere, and then the bonus rounds or bonus stages. I guess that's fine too. Not that you would necessarily want to load the bonus stages, because you can't really do much with them. Bonus stages, and there's 20 of those. So we copy this. Oops. Oh yeah, I do need the thing to switch rows. 20 stages, start X, current Y. Okay, that's good. Yeah, that should be fine, right? Bonus stages, it's a little bit too much down. Why is it so much compared to the others? Oh no, I need to add some stuff here too. Bonus stages. No, so special rounds needs to add 100 added to it. All right, and then the bonus stages are fine. Why is this too much? That's weird. So we have special rounds and then the numbers plus 0.1. Like why is that so much? Okay, these need more spacing though. Special rounds. This needs to be 12 or something. Okay. And then the bonus stages. I mean, I guess it's too much. Okay, now let's make it a little bit bigger. So we start at 85 and okay, 85. What does that mean? Wait, so that's 85% of the height, right? Of the top height. All right, so we have 15% at the top and 15% at the bottom. Out of 2. Is that 85 then? I'm not sure. I guess it is. Okay, so now we can spread. I mean, I need some extra space in case I want to load a level made by a player, right? So if I'm adding saving of levels to like a database or something, I need to be able to query those and load those here. Yeah, I mean, it doesn't look nice, but it's fine for now, I think. I have to put an X to close it. And let's just add a little bit more space to use up the entire space here. So bonus rounds gets a bit more here, and then special rounds as well. Yeah, like this. And then we do a close button. 1 second. Let's put an X in the corner. And what is the width? Width was half, I think, right? So that would be So we're 0 in the center, 0.5, I guess. So this would be at 48. Well, no, I mean a little bit more, I think. And then the y would be 0.85 or negative 0.82 or something. Does that position it in the top right corner? Yes, but we have to adjust a little bit. So a bit more to the left. Okay, that's fine. Yeah, okay, so how do I prevent this from clicking underneath though? Like that's not good. Yeah, I don't know how to do that. So if I say pixie container prevent interaction, how to disable all children. Okay, this is not formatted. Interactive button mode true sprite click function. Okay, sure. I can get yeah. I just have to put interactive thing to false, I think. So let's see if that works, right? I have to have a show pop-up function, which then does that, right? So show pop-up. I guess I'm gonna have to make one specifically for the import pop-up though. Yeah, that would make sense. So import pop-up, and then we have a hide import pop-up button too, which then does the inverse. So show import pop-up needs to pop-up import container dot, what is it, show? Visible. And then let's see if when creating it, we were setting this to false, right? So yeah. Okay, let's see if it hides it now. It does. And when we need this button here, this import button needs to have a click function, which then shows our show import pop-up. Okay, so that should work too then, right? Import. Oh no, I need to add these guys too, of course. I'm just gonna do that. Right, that works. And I can do the hide on the X. So I need to do this. Close button, hide import pop-up, which we will then implement as like this. Visible is false. Okay, so we can import and close. That's good. But now we need to, so that still double clicks here, right? That no, it doesn't. Okay, because it swallows the event. Okay, sure. But yeah, this still does. Now all the other ones have to be disabled, right? So what containers do we have here? Where do we use this? Oh, right, that's the HTML element. So we have the Chrome container has to be disabled, construction board, tool, and power up, right, and the buttons too. Okay, I need to remember these. So we have Chrome container, construction board, tool. Don't remove them. Power up container and button container. All these have to be interactive false. Does this work? Nope. That does nothing at all. It was interactive, right? No, not this one. Prevent interaction. Yeah, interactive is false though. Why would that not work? Not sure why the first case of disabling interaction on a parent object doesn't affect its children. Why would it not? Can I like enumerate all the children or something? That would suck though. And it has to be recursive though. I don't think I went too deep, but like, I mean, it's not going to be recursive though. Like, which one? Let's try with Chrome container. I think Chrome container contains the. Oh no, that's the tool container. So this tool container, children for each child interactive is false. Do I have to put this in a function? I guess. Doesn't give a fuck. Wait, these are added to tool container, right? Yeah, that is exactly that. So interactive does nothing. Wait, oh no, I'm making a mistake here. Yeah, it does work. I made a mistake. Okay, so it's the direct children, but not the children of the children. I don't think I went 2 levels deep, so I guess it's fine. But sure. Yeah, okay, so let's do that then. So we have a list of containers. Okay, does this work then? Import. This doesn't do anything anymore. This doesn't work. Perfect. The buttons don't work either. And the round numbers. Okay, this is what I wanted. Good. And this should do the opposite because now the thing is frozen, of course. Okay. Nothing works. Close, and it works again. Okay, very good. What do we do now? We make the things clickable here. So the X is clickable, sure, but we need to make these round numbers clickable as well. Regular rounds, yeah, it's this one here. So a round number has to be static pointer for cursor, and it has to do something. What do we do now? I guess it's the same as here, right? As in our constructor here, we fetch a level, and that's it. Let's reset it to 1. So we call the fetch function, and that loads that level, that round number from 1 to 125 into. Okay, no, it loads it and it inserts it where? Yeah, it inserts it in the current round number we are looking at here. Right, so we just have to call this one, right? No, not there. It's here that we are. So it's just a matter of fetching this one. With the correct value being, yeah, let's go through the event again. Round number, and then we'll just round a number. Equals, where is our iteration? I, right, from 1 to 100, that should do the thing, right? And so we're fetching the Eggerland level in the current round, and we close the pop-up. So round 1, we import level 84, and we import level 84. Simple as that. Round 80, and that. So if I do it in the third one, we import level 43. Works perfectly. Also, let's see whether the power-ups are handled correctly. Level 8 has a power-up, and it doesn't work. Okay, that doesn't work. Why does it not work? It's an update thing because it has loaded it. That means that our fetch level here should do the update power-up. Why do we not do that here? We have to. Oh, yeah. So that's what I fixed before. Because at the start of when you load the page, it loads level 1, 2, 3, 4, 5, and it does an update every time you load a level, right? So if the first level, yeah, so it updates the last one for level 5, but if level 1 has updates, it would hide it. So I have to do it here and in the other place at the top. Okay, so but that should work though. So I'm going to level 3, I'm importing level 8, and I have my power-ups, yes. Okay, I can just, and then, well, the special rounds I still have to do. Right, and that's level 100, I do recognize that one. Yeah, so that works neatly. Okay, now let's load the special rounds. So we have this stuff here. We have to do for these guys. Let's put the position at the top. Now it's just not, it's this plus 100, right? Yeah. So that should work too now. we import special round 101, that's correct. 102, 3, 4, and 5. Yeah, I think that's the last special round, the extra difficult one. And now the bonus stages. And that is plus 105. And that should work too now. Import first bonus stage. Yes, that's correct. And that's the last one. Yeah. Okay, that works. Wait. 20. Wait, is that the same? Why is that the same? Did they actually? I don't remember that actually. It looks like 1 and 11 and stuff is all the same. Yeah. Wait, that's weird. Did I make a mistake here? So bonus level 1 is this one, right? That's the, okay. And then 11. Yeah. Oh, does that repeat in the game too? I didn't know that. So we only have like 10 bonus levels and they're duplicated. I wasn't aware of that. I guess we'll have to look in the game though. Let's see if that is the case. So we have our, I'm gonna have to look in the thing here though. Wait, so if we want to do level, so bonus level 1 happens after level 5, right? After 10, 15. So this is after level 50, I guess. Well, 55. Okay, so we have to go to level 55 and cheat, I guess, because I'm not going to be able to clear that thing. What is 55? Is that a difficult one? Yes, it is. Wait, no, we can fake that. Wait. Okay, so let's see. Where are my symbols here? Current level is C81B. Okay, we have to have this. C81B. Okay, let me activate MSX here. Okay. C81B is our current level. I'm going to load a save state that's before exiting a level. Not this one. Yeah, this one, for example. And then I'm going to say, which one did I want again? I already forgot. Yeah, bonus round 11 would have been so 55, right? 55 is the level we have to have just completed. And then we go to bonus level 11, right? 55 in hex is 37. So if we change this to 37, yeah, so now we've finished. Okay, no. Okay, I hit the time travel thing. 37. Okay, so now we're exiting level 55 and we're going to bonus 11. Yeah, and that's the same one as bonus 1. I don't know why they did do that. Like, why would they repeat 10 bonus? I mean, I guess they didn't make 20 levels, they just made 10 bonus levels. And yet they point to different data though. Well, I'm not sure actually. So if we go look at our bonus level pointers, so at the start here we have pointers to bonus level data at 6D80. So if we go look at these pointers, so so F8 D5 here, that's the first 5 levels, right? Then we have, so for 100 levels, or 105 I guess, we have these pointers, and then this one is the first that points to bonus level data. And we have 1 pointer, 2 pointer, 3 pointer, 4 pointers. 4 times 5 is 20. So we have duplicated data in the ROM because, oh no, look. It's 2 pointers, but they're the same. So 5, so actually 8955 is here too. So they're pointing to the same data, 7A, 8A, yeah. So that implies we have fewer data in our ROM available. Instead of 125 levels, we have 115, right? So that means we can only have a maximum of 10 bonus levels. We just duplicate them. Like bonus 11 is the same as bonus 1. I guess, I'm not sure if they ran out of space or something, or what the exact, or they didn't just didn't have time to create 10 more bonus levels. I don't know what the reason behind that is. But yeah, the pointers are the same. I didn't see them before. 5, 5, 8, 9, 7A, 8A is repeated here. That's cool. Okay, so it wasn't really necessary to include 20 bonus levels in the thing here. But yeah, it is what it is. It's fine. So yeah, we can import bonus levels now. That's good. Or all the levels, I guess. Which is pretty cool. And we can change them, of course. We can put whatever we want in there. Oh yeah, let's commit this, because this is correct, right? This is everything we needed to do for our pop-up import. Yeah, that's fine. Oh no, I don't need to comment this out. This is based on a variable. Yeah, import button. I mean, I should put a brick wall around this though, if I want to make it a bit more aesthetically pleasing. And I think I can also put a blur filter on the background, which might also be interesting to do. But that's not for now. So let's see, now all that's left is the export, of course, right? That's the big one, although it wouldn't be that difficult, I think. I don't think I'm missing information. There's just one unknown, and that is the header of the disk file, of the puzzle file on disk. I haven't looked into that, if that's relevant at all, or just an indication that says, okay, this is in an Eggerland puzzle file. But we'll look at that in a moment. Yeah, this works. Okay, so okay, we have importing of levels and now exporting. So all we have to do is just write a file and download it. A file containing the 5 levels that are in memory here. And we also have to do sanity checks. Right, we have to do the sanity check of the amount of mobs in the level. That's limited as well. And we have to do our sanity checks, as in, is Lolo in the level, and is there an exit in the level? And then we just have to write the file, right? I'm going to take another look at a puzzle file. And so, for example, this is a file we have to write out with containing all the data, right? So these are the first 5 levels. And it starts here because the first level has no power-ups, so we have 3 zeros at the start, right? I do not know what these first 8 bytes mean. And I'm gonna see, can I do multiple windows here? Of course I can't. I'm going to open another puzzle file and see if these values differ. Okay, they're the same size, of course. Yeah, so they do differ though. So FE, F8, D5, this one differs. FE, F8, D5 is the same, but 72 is C9. D6 is the same. I wonder if that's relevant. What is 72? Could it be like total size or something? 72. I mean, I can reverse engineer that in the code though. 114. Well, no, 72. 72 would be here, right? No, would be here. But we still have quite a bit left. Like it's not an offset. And C9. Well, C9 is, where is it? C9, where is my indicator? No, I don't have an address. Oh yeah, no. This is C9. So how many bytes after this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bytes after this little variable. So this is 17, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that's interesting. Why would it point to the last 14? Because we're only skipping like 8 or something here, right? Not 14. Yeah, and I'm probably gonna have to know this value, otherwise it won't probably work, right? Let me open another one. Do I have another one? Yes, I have another one. Yeah, but this is a duplicate from the first one. Yeah, C9. Yeah, this is identical. This is also the first 5. Let's see, do I have others? I have powers. Yeah, I have a 4th one, but I don't know if I have changed stuff here. Yes, it is different though. So C9 here becomes B5. B5 is indeed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bytes. I mean, if it's simply that, I don't know why that would be the case. Why it is file size minus 14 bytes. But at least it's consistent though. And the rest is completely the same, right? D6 and then 2 zeros. 2 zeros and wait, no, this is different too though. For the first 3, these are all zeros. So where does the level start? I think the level starts here, right? We have 3 power-ups and then low-loss position, exit position, and then data, right? So it starts here. It starts here. Right, because these are my power-ups. So in this, yeah, so for all these 3 guys are all 0 for the first 3, and they are different for this one too, though. Crap. So we have 2 unknowns, because the rest is all the same. Yeah, that means I'm gonna have to look into this assembly to see what these first 8 bytes means. 8 bytes mean. I'm not sure what that what that's about. Yeah, that sucks. That means, I mean, I can attempt to write that stuff out though. Like I can put a 0 here and then subtract 14 from the file size and put that here. I can do that, of course. But I'll have to look in the disassembly to see what it is actually about. Okay, let's try to write a function that does the encoding instead of the decoding. I haven't written that yet. So we have to re-implement our algorithm here, and there's two. So there's two algorithms that define the data, right? You have a horizontal and a vertical one. If you look at the code here, so we have two algorithms. Actually, I have this in C++ as well, which is a bit more clear. So yeah, we have a horizontal algorithm where all the it's run length encoding. It's RLE, but you can do RLE horizontally or vertically, of course. And the first one is a horizontal RLE. So we save we're using byte per byte, right? So 1 byte contains 3 bits at the top, at the bottom to indicate how many times we have to repeat the top 5 bits. So the block value is just the top 5 bits. We don't even have to shift to the right. It's just a value, the top 5 bits as a value. And then the bottom 3 bits plus 1 contain the amount. So what I think they did, and I'm not sure about that, it's like you have the same thing horizontal or vertical, right? And it totally depends. It looks random, like which algorithm they use for storing these. What I think they did is they had all their 115 levels, right? So not counting the extra 10 bonus levels. They have data worth of 115 levels, and they want to make it as small as possible on the ROM, because all these bytes have to be stored on the ROM, of course. What I think they did is they ran all the levels through both algorithms and took the smallest one of each, and that's how they determine whether it's horizontal or vertical. I think that's what they did. Once we implement both algorithms, we can simply try to choose a different algorithm as they chose in the ROM and see if it still works. And I'm pretty sure it's going to still work. But yeah, I have to do some analysis on the fact like that my assumption about the sizes is correct. And I think it is. So we're going to start with the easiest algorithm, which is the horizontal one, where we just have to loop horizontally and keep a tally, right, of do a run length encoding. I'm gonna have to think about that though, but sure, that's no big deal. So our maximum repeat count is 8, I think, because we have 3 bits, but we do +1, so the bottom bit counts as well. So yeah, 2 to the 3 is 8, of course, 2 times 2 times 2. But we're adding 1 because otherwise, so we can reach 8, as in not 7 as our max. Right, because bits, you have 1, 2, and 4, that's 3 and 4 is 7. So our max repeat with the 3 bottom bits would be 7, but 0 doesn't make sense. A repeat count of 0 would just be omitted. Like, that doesn't make sense. You wouldn't have that in a run length encoding, so they add 1, meaning we can reach from 1 to 8 as a repeat count, right? Okay, I've never implemented a run length encoding, so I'm gonna do some attempts here, but it shouldn't be that hard. So we put the decode in the constructor of a round class. Yeah, I need to refactor this a bit because our actual story of data, the storage of data is in this variable here. So I need to put this in the construction mode function, but that's fine. We can just do an encode function, initialize buttons. Okay, so I think I have a load function somewhere. Yeah, fetch. Yeah. Okay, we have a decode Eggerland 1 round data. Okay, so encode. Should I get it the data? No, I don't want to do that. I just want a round number, right? And this is going to be the 1 based round number. Okay, yeah, it's it's 1 based because we're going to use current round number probably. So the data equals, which is the block data or blocks, equals this construction board data round number. That's it. And we have our power-ups we need to know, and then we need to know the exit position and low loss position. Okay. Power up data equals this power up data for round number. I think this is -1. I need to fix that. Some shit is 0 based, other stuff is 1 based. That's not good. Yeah, so it's an array of 5 and it starts at 0. Okay, that's not good, but we'll fix that later. I'm again working in the diff here. Okay, so we have this, and let's log that. And then let's call this from the function, the export function. We need these guys. Let's make the export button do something, actually. Encode Eggerland 1 round data for this current round number. That doesn't really matter. Later on, we'll do it for all 5, of course. I'm just testing right now. Okay, so we're calling this function and we should log this. Okay. So we're exporting, yeah, so we have our blocks here, that's this array, that's correct, and then we have our array of power-ups, which there aren't any. I mean, I can give them some. Wait, what? Why does this not work? Oh, yeah. Okay, there's only 6, yeah, it's clamping to 6 hard framers. Okay, so export again, and now we have our 1, 2, 3, 6. That's fine, and we have our block data as well. So we start with encoding the power-ups because that's the first 3 bytes in our data, right? If we go look at our data here, this parses the data, and the first. So 0, 1, and 2, the 3 bytes at the start are the power-ups. We have to encode those though. So we need to shift those 6 to the left, right? Yeah, I think so. And then we simply add our number of hard framers. Yeah, that should do the trick. Okay, so I guess we have to do a simple array, or do we do a uint8 array? Do I need to give it a length? I don't know that that's the case. I think a uint8 array will be easier if we have to write a file out later on. Constructor. Okay, is there no link to a constructor here? Length or just empty? Great. Okay, do we not have explanations now? Parameters, C type array. Very clear. Omitting all parameters is equivalent to using 0 as length, but can I just push stuff on it then? I don't know if the uint8 array has push, because that's an array thing, right? I don't think I can push here. Static methods. Instance methods. I don't see a push. So I guess we don't know the length yet, so I can't use the uint8 array, but I think we can convert anyway if we need to. But now I can use push, right? So I can just add stuff after. Right. First power up, we have to do this 3 times. Because we have 3 power-ups. What are we pushing? We're shifting the ID 6 position to the left and adding the HFC, the hard frame counter. Right. So power up data I dot ID shift 6 positions plus power up data dot HFC. Is that correct? I think so. Let's see, console log data. Let's see what that gives us. I'm not gonna dump the blocks, but I'm gonna dump the power up data. We have to put some stuff in there though. Okay, so that's not correct. That's 1, 2, 3. That can't be the case, right? Do we not do bit shifting in JavaScript the same way we do it in C++ now? Oh, okay. Stupid brackets behind my back. Didn't see that. Okay, that doesn't work. Let's first dump the values. Let's see if that works. And export. So 2, 128, and then 0 for the rest. Okay, that does work though. Like, so 2 becomes 128. Is that correct? 128 decimal. No, it's in this 8th bit. Oh yeah, no, 1, 2. Yeah, that's correct. Low. Yeah, because it's 2, right? Yeah. Wait, let me do all of them. Okay, let's 1, 2, and 3, and export. So 64, 128, and 192. So 64. Yeah, that's 1 in the 7th bit. Then 128 is 1 in the 8th bit. That's 2, and then 3 is both. Yeah, that's 192. Yeah. So that's correct though. And then, oh, God damn it! I didn't index. Stupid mistake. Right, that looks better. So we have 65. 65 has 1 in the bottom 6 bits. That's correct. That's this 1 here, and then the type is 1 as well. And then we have 130, which has 2 in the bottom thing, right? And then 2 in the top thing. 2 is an arrow, okay? And then we have 195, which has 1 plus 2 is 3 in the bottom 6 bits and 3 in the top one, which is a thing. So that seems to work though. Right, so let's put some more extreme values. So that should, right, I'm doing that check, of course. Well, yeah, I mean it's gonna work though. That should work. So that's the data for the power-ups. That's already done. What else do we have then? Then Lola's position and the exit position. That is going to be a little problem because it's BCD, I think. So when we look at this data, for level 1 here, we have Lola position is 0, and in 0 means, so 0, 0 hexadecimal means 0x and 0y. If we look at the exit position is 8, 5, which means 8, 1, 2, 3, 4, 5, 6, 7, well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, y, right? So 8, 5 is literally x 8, y 5, which is quite clever, but how to encode that, right? I have to think about that. So let's first find the index from 0 to 121, or from 1 to 121 of this thing, right? We're not going to take Lolo because it's always going to be 0. It's at position 0, so that's fine. Okay, we have to find get a function. Well, no, I can just, how do I find the index of an ID in the array though? Let me think. I mean, we can do brute force stupid stuff by just looping, which is, I'm guessing, what we're gonna have to do. Because I need the index. I can't use the filter function or whatever because I need the index, right? Yeah, let's do it stupidly. Okay, let's do the exit position first because that's the one that has a better value. So exit index, meaning from 1 to 121, 11 by 11, is, how do we do this? Equals, let's start at 0. Do we not have column 11? 11 is what? Blocks per row. Well, no, that's in the round thing though. Construction board width. Okay. Okay, so we're looping everything here. The sprite equals this construction board data I. No, this has to be this current level. Well, no, no, round number. Wait, no. We have to index in blocks. Because I already figured it out. Blocks I. Yeah, I have that up there. So blocks I. If sprite equals this cell exit, or sprite equals this cell exit with emerald framer on top, then we break because we have found exit index equals I. Okay, that's a stupid way of getting the exit index, but sure. Okay. That would be 63. Right, and we have to convert that to 85. So 63, knowing that it's 11 wide, we have to do just some modulo math to convert an index into an XY position, right? That isn't that hard. So I think that exit Y equals, and I'm probably gonna have to change this because probably not gonna be correct from the first try. I think that would be exit index modulo construction board width. Yeah, and that would be the floor, right? Or no? And then exit Y, exit X equals exit index minus exit Y times this construction board width. I think that's the case. Exit index, exit X, and exit Y. No, so the first one is incorrect, exit X, but Y is 8, but that should be 5 though. Wait, so I'm wrong. So exit index, wait, I mean, we're right? 11, 22, 33, 44, 55. Let's count better. 11, 22, 23, 20, 33, 44, 55 is here. 56, 7, 8, 9, 60, 61, 62, 63, but it's 0 based. Okay, so yeah, that's +1. So that's correct at least. Yeah, so 63 modulo 11. What is that? No, I have that in my thing here. I don't have modulo. Oh, do I have a programming thing? Well, does that have the eight? What? So it's 5 times, that's 55 plus 8. Yeah, okay. 55 and 5 and 3, yeah, okay. So the modulo is 8. Oh, no, I need to divide and floor, right? Yeah. I don't know why I was doing modulo here. I just need to floor. Right. No, not modulo. Yeah, those are the 8 and 5, because 85 is what we need to have, right? 85 is our target here. So we are at x8, y5. Yeah, well, I don't know why I was doing modulo here. And then it's basically, oh yeah, but I have to do this in hexadecimal though. Okay, how do we do that? Because I can't do 8 times 10 plus 5, right? Because that's 85 decimal, but that's not 85 hexadecimal. I think I'm gonna have to think about that though, because that's not something, well, it's BCD, but oh, right. These are the bits, right? So I can shift perhaps. If I shift 8 4 positions to the left and I add the bottom one, does that work? Right, does that work? So exit X shifted 4 positions plus exit Y. It's going to do it in decimal, of course, but I can convert that. That's fine. So 133 is the result. No, not you. Yes, that's 85. Okay, that's the solution. Yeah, we just shift 4 bits and then we add the bottom 4 bits. Yes, that works. So this is our algorithm to convert our position, right? I mean, we can do the same with Lolo now. We should put that in a little function though. Can we do inline lambdas here in JavaScript? Can we do this? We need a so indexes. So the first one it encounters, it returns, right? So well, let's call it index. If cell indexes contains, do we have contains? No. Do we not have contains? No. A find perhaps first element in the provided array. What does it return the index to? Return value, or the element itself. Okay. If indexes.find sprite wait, oh, no. Right, if the sprite is found in the provided array, then we stop. Right. Oops. I think that's correct. And then we have our index, and then we do this. Well, that could be y and x, and then return x plus y. Okay, so does this work? And this becomes this Celolo, and this becomes exit. And then let's dump these values, Okay, does this do what I hope it does? Nope. Sprite is not a function. Find sprite. Where am I using sprite as a function? Array we have to call that differently, right? It's array.find or something. Yeah, of course. Well, no. By one of its properties. No, I just need to find a prime number in an array. I just need to find the thing though. Oh, we have a find index, which is what we need, right? Right, let's do this. Let's do this. Yeah, so this was the dumb way of doing it. I think we can do this more better. Blocks.find index of, and then a little function. Let's call it element as well. And then cell indexes dot find L not equals undefined. Does this work? No, L is not a function, but yeah, it's this one that's. Oh, yeah, no. Okay, so JS array contains value includes does work though. Oh, I did contains. I did not do includes. Exit y is not defined. Okay, that's something that's left over. Right, it's y here. Grab zeros all around. Right, for the first one, that's fine. Because let's disable this one for now. Okay, it doesn't find, so blocks find index. And for each element, and the cell indexes have to include. I mean, this is correct though. Oops. Yeah, we have an array 240 and 248. So that should give us true. Yeah. And let's put this in a little function so we can type some more stuff. I think we have to return this though. So these are all the elements that are being tested. That's nothing though. 136. Returns the index of the first element in an array that satisfies the provided testing function. Oh, damn it. Okay, so now we're looping all the elements, all at least, but we're still not dumping the correct thing though. So index 63. Okay, so that seems to work. Okay, so we can return this to its original form. Okay, so the found index was 63, right? Which becomes 133. Yeah, that's 85, right? That was what we needed. Yeah, 133, so that works. What are we doing wrong now? Exit position. I'm wondering what is this array of 3 things is at the end here. Why did we overwrite data or something? Oh, no, that's our, okay, never mind. It's our binary data we are actually creating. Right, so we have low position and exit position done. Oops. Right, 0, 0, and 133 is 85, is 8 horizontal, 5 vertical. Let's change them. Let's put it here. That would be 11, 11, right? So BB, I assume. It's 170, and is that BB? No, 170, well, AA, right, because we're doing 0 based, it's from 0 to 10, right. But yeah, that's AA, that's correct. Excellent. So we've done it a slightly smaller, smarter way. Now we do have to add that to the data. Right, that's correct. What do we have now? So we are here, we did this, and now we need, right, the data length and the algorithm. So we're just adding the, oh yeah, we don't know this yet, right? We have to do the algorithm first, and then we can determine the length, and we just combine the length and the algorithm chosen into these things. So just we have to implement the horizontal algorithm now. But I'm going to end the stream and eat something. I guess we'll have to keep this for next time, which will probably be tomorrow in the afternoon, perhaps. So thank you for watching, and maybe I will see you tomorrow. Bye bye.